going to look at this graph of y equals 3x minus 2. So to graph an equation, you simply plug in your inputs, your x values, and see what you get out for your outputs, and then you can plot those points on the coordinate plane. So let's do y equals 3x minus 2, and we're going to substitute in this negative 2 there. So y equals 3 times negative 2 minus 2, which is negative 6 minus 2. So we can see when we plug in negative 2, we get an output of negative 8. Now if you were going to go ahead and do that for the next 4 ordered pairs, if you plug in negative 1, you should get negative 5 out. If you plug in 0, you should get negative 2. An input of 1 will get you an output of 1, and an input of 2 will get you an output of 4. Now that you have those inputs and outputs all filled into your XY table, we just have to graph those. So our first ordered pair, negative 2, negative 8, we're going to go to our origin, go 2 left, and down 8. So your first point will be way down there. Negative 1, negative 5, go left 1, down 5. 0, negative 2, over 0, down 2. 1, comma 1, right 1, up 1, and 2, comma 4, right 2, up 4. So if you notice, those go in a straight line, which they should. So we're going to go ahead and draw a line through those points, and that would be a graph of the equation y equals 3x minus 2. Okay, so one last thing that we need to talk about is the different kinds of equations. So the first that we're going to talk about, which we've talked about a lot so far, are these linear functions. And those are always in the form y equals mx plus b. And they always have an exponent of 1 on the x variable. And the graph is going to look like a straight line. So if we would have our y and our x plane, this would be an example of a linear function, straight line. We're going to talk about quadratic functions a lot this year, and those are in the form y equals ax squared plus bx plus c, where your x has an exponent of 2, and this graph is going to look like a U. It's a U-shaped graph, which if you recall, we call a parabola. So if, again, we have our x-axis and our y-axis, a parabola would be this kind of shape. And that is called a quadratic function. All right, so if we take a look at one more thing here, this function notation, really the only thing you need to know about it is that instead of y, we use this f with x inside parentheses. So how we would read that is f of x equals 2x plus 3. Okay, and it is really useful. So like if we look down at this example below, if x is 5, then f of 5 would equal 2 times 5 plus 3. So f of 5 is 13. Okay, so that's pretty useful because we know if we plug 5 into the function, we would get an output of 13. Now, if we weren't using function notation, we would just write y equals 13. Well, I don't know what value for x was plugged in to get that y value. Function notation takes care of that because you know you plugged in 5. So let's practice using that in a couple of examples. We're going to say f of x equals 4x minus 8. So let's evaluate that when f is negative 2. F of negative 2, we need to replace all of the x's in the function with negative 2. So we'll have 4 times negative 2 minus 8, which is negative 8 minus 8, and that's going to give us negative 16. So for this function, f of negative 2 equals negative 16. Now I encourage you to pause the video and see if you can do the next two, f of 3 and f of 0. So pause the video now. Okay, so hopefully you got a chance to practice those two. When you did f of 3, you should have found an output of 4. And when you did f of 0, you should have found an output of -8. All right, so if you did those correctly, nice work. If not, just go back and make sure you correct those mistakes. And our final example for today, we're going to graph the function f of x equals x squared minus 2x plus 1. So you notice we have a power of 2, which is going to make this a quadratic, and our graph better look like a parabola when we're done. Let's plug in the first point together. So f of -3 means we're going to plug in this -3 everywhere we see x. So we'll have -3 squared minus 2 times -3 plus 1. If we evaluate that, -3 squared is 9. -2 times -3 is +6 plus 1. So 15 plus 1 will give you 16. Okay, so I encourage you again to pause the video and evaluate those other 6 x values. See what you get for y. So if you would like to pause the video now and give that a shot, you are more than welcome to do that right now. So if we just go ahead and plug in what you should have evaluated, when you plugged in 2, you should have gotten y is 9. When you plug in -1 to that function, you should get an output of 4. 0 will give you an output of 1. Notice that's this right here. It's kind of like the y-intercept. When you plug in 1, you should get 0 out. When you plug in 2, you should get 1. And when you plug in 3, you should get 4. Now let's graph those. This first ordered pair you probably won't be able to fit on the graph because 16 is way too far up. So let's start with -2, 9. So go left 2, up 1, 2, 3, 4, 5, 6, 7, 8. And it'll be a little off the graph at 9. If we plot -1, 4, we'll go left 1, up 4, 0, 1, go over 0, up 1. 1, 0 is right 1, up 0. And 2, 1, go right 2, up 1. And then 3, 4, we will go right 3 and up 4. And if you were to plug in 4 for an x value, you would actually see that you'd get +9 out. So notice that those are symmetric, which parabolas always are. And we're going to do our best to draw a nice smooth curve through those points. And that would be the function